In this video, we're going to go ahead and work on an example regarding finding the derivatives of inverse functions. So we're told that functions f and g are inverse functions of each other, and we're given what f of x is. It's 2x to the 5th plus x cubed plus 1. And we're also reminded that f of 1 equals 4. And how would we know that f of 1 equals 4? Well, obviously we could just plug in 1 everywhere we see x, and well, 1 to any power is just 1. So this is 2 plus 1 plus 1 or 4. So this statement is also true. I should also note that they're inverse functions of each other. So I'm going to note that. And we're asked to find g prime of 4. So what exactly is g prime of 4? Well, secretly they're actually asking us an inverse function derivative question. Because remember, g is an inverse function of f. They're inverse functions of each other. Because they're inverse functions of each other, that means if you do something like f of g of x, f of g, because they're inverses, they will undo each other, and so you will be left with x left over. And so again, if you were to take the derivative, we would get our whole derivative rule. And I'm going to go ahead and copy our derivative rule that we derived in the last video. So there's our derivative rule that we derived in the last video. I'm just going to leave it right there for easy reference. And so we're asked to find g prime of 4. So really, we could actually go ahead and we could replace everywhere we see an f prime, we can go ahead and replace in this rule. I'm going to pick a better selection. We can replace it with a g prime of x. So let me get rid of that, and let me go ahead and get rid of this f inverse over here. We're going to call that. We're also going to call that g of x. So we're going ahead and we're finding that g prime of x equals f prime of g of x. We need 1 over. So basically, in order to find g prime of 4, I'm actually going to write this over yonder, over in this space where you can solve it. So if you want to find g prime of 4, well, we can simply plug it into this equation that this whole rule, this theorem that we've developed. We can plug it into this theorem over here. So we're going to get that g prime of 4 is going to be equal to 1 over f prime of g of 4. So in order to begin, we're going to want to know, well, what f prime is. So let's go ahead and calculate. Let's see if we can, off to the side, find out what f prime of x is specifically. Well, f prime of x, we can go ahead and do on this term, we're going to do the power rule. So we're going to bring the power out front. So 5 times 2, that's 10 times x to the 5 minus 1 power, or x to the 4th. We're going to add it to x cubed. We're going to want to, using the power rule, we're going to bring the 3 down in the front. So it's going to be 3 times x to the 3 minus 1, or x squared. And then the derivative of 1, that's the derivative. That's just the derivative of a constant. That's simply just 0. So now what we're going to do is we're going to go back over here. And we know what f prime of x is. We want to find specifically what f prime of g of 4 is. Well, I'm not confused. They didn't tell us what g of 4 is, so how can we find g of 4? Well, we were told again that f of g, they are inverse functions of each other. So what does that look like? Well, if we have some input x, and we apply the function f to it, we input it into the function f, we are given an output of f of x. And we recall that because they are inverse functions of each other, if we put that output f of x into g, it's going to give us our original output. It's going to give us our original input if we put our output f of x into our function g, because f and g, they undo each other. They are inverses of each other. So if f of 1 equals 4, well, then g is going to take this output and it's going to find that input. So that means g of 4, that simply equals g of 4, that's simply just 1. Because again, if f goes one way to find an output, if f is going one way, taking an input, and we're applying f going to the output, g is going to take that output and it's going to find that original input. So g of 4 is 1. So now we can go ahead and continue working out this side over here. We're going to get that g prime of 4 equals, it's going to equal 1 over f prime of 4. It's just going to equal f prime of 4. And f prime of 4, well, that's pretty easy to find. We can just plug in 4 into this equation. I'm noticing that that's going to come out to be a super big number, and I feel like I'm doing something wrong. So hold up just a minute. Actually, it's not going to be a huge number. I lied. I just went through all of this saying that the g of 4 is 1, and then I went and put 4 in here. It's not. It's f prime of 1, because g of 4, remember, it's going to go backward, and it's going to be that output of 1. So I messed up there, so I fixed that. And we can easily compute what f prime of 1 is if we look over here. Well, 1 raised to any power is just 1, so it's going to be 10 plus 3, or 13. So g prime of 4 simply equals 1 over 13. That is the correct answer, and we are done. And that is an example problem on finding the derivatives of inverse functions.